You're watching the Weiss channel. Da 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 da.
Go ahead.
Wow.
You gonna make that?
You stole that. They gonna be like,
Okay. So for the last few weeks we've been doing congruent triangles. Today we're going to do triangles that are similar. Similar triangles. Meaning you could have two triangles that are the exact same shape but different sizes, okay? They could be the same shape but different sizes, okay? So the question is, how are they similar? All right? And basically that's going to be SSS, SAS, ASA, or AA. Not AAS, just AA. I'm going to show you what that means in just a minute. Okay? So we're going to start here. All right? Are they similar? Well, first of all, what does the 25 correspond with here? Say it. 5, right? Okay. So I'm going to put 25 over 5. What is 25 over 5? 5, right? So, what does 40 correspond with?
8.
8, right? I'm going to put 40 over 8. And that is 5, right? What does 50 correspond with?
10.
10. I'm going to put 50 over 10. 50 over 10 is 5. Okay? So, and by the way, if I did 5 over 25, that would be 0.2. If I did 8 over 40, that would be 0.2. If I did 10 over 50, that would be 0.2. And they all match, right?
Mm-hmm.
So, that is called side, side, side. Does that make sense?
Mm-hmm.
All three sides of one triangle match with all three sides of the other triangle. Okay? That's called side, side, side. Now, you also need to tell me, what does triangle BCD match up with? It's this symbol means similar. Notice there's no equal sign below this little wavy thing here. This wavy thing means similar. Okay? BCD is similar to what? B matches up with what?
L.
No.
I mean
B
J.
is like J, right? Triangle J.
Okay.
What? Now, what does C match up with?
K.
K. J, K, and then D matches up with L. And that's how you do the problem. I need two things. Thing number one is BCD matches up with what triangle, and then I need you to tell me what is the similarity. This is called SSS Similarity. Are we okay there? Can I have a nod, please? You understand what I'm talking about?
Yes.
Okay, thank you. All right, now, over here, all right, do you see how you have two sides with this one and the angle in between? You see how you have two sides in this one and the angle in between, right? What do you suppose that's called? If you have two sides and in between the sides there's an angle that's congruent to each
Side,
other.
angle.
Side, angle, side. Right? Does that make sense? That's side, angle, side. Okay? Now, here's what I'm going to tell you for purposes of today's assignment. Everything is similar. You don't have to check whether or not it's similar. We already checked, okay? But you don't have to. I'm going to tell you that all of the numbers are proportional, okay? All of the numbers are proportional in today's problems, okay? They're all similar, okay? You need to tell me why. This one is side, angle, side. Can I have a nod one more time? That makes sense? Okay? So Q here matches up with what here?
Q.
Q. Very good. All right. R matches up with what?
F.
It's going to be F, okay? And S
G.
matches up with G. Okay? So sometimes it's harder to figure out, but can you see that like F is almost a right angle? And R is almost a right angle? That's why those two match up. Okay? Okay. Over here, now, let me ask you a question. Let's say we had two triangles. Okay, and I told you that this here was 90 degrees, and I told you that this here is 60 degrees. If I tell you this here is also 90 and this here is also 60, okay, what's 90 plus 60? What is 90 plus 60? 150, right? 90 plus 60. Sorry, 90 plus 60. Does everyone agree that's 150? The three angles of a triangle add up to what?
180.
180, right? So if this 90 plus 60 is 150, how many more to make 180?
30.
30, right? This one has to be 30, right? Over here, if this is 90 and this is 60, what does this one have to be?
30.
It has to be 30, right? Does that make sense? Here's the point. The point is, if you have two equal angles in both triangles, then the third one has to be equal. Does that make sense? You don't have to call it AAA, because you know if you already have two, you have to have the third. Okay? You know what that's called? That's called AA Similarity. Angle, angle. Okay? That being said, do you see that you've got two angles here congruent to two angles here? Are the two triangles similar?
Yeah.
And what's that called? AA. It's not called AAS. It's just AA. Okay? So we call that AA. Over here, UVW is similar to what? You see how U has the 1 mark here,
C.
right? Where's the 1 mark here? C, right? V has the 2 marks. Which angle has the 2 marks?
D.
D. And the other one, of course, is going to be E. That's how you do this, okay? Over here, all right, I'm going to do this. I'm going to say, all right, I've got the bigger triangle, and I've got the smaller triangle. You see how I have two triangles here in this picture, right? I have L here, I have K here, I have M here. I have E here, I have F here, I have K here. All right? Now, this is 60, that's 60. 55. And what's 12 plus 18? 12 plus 18 is 30. Does everyone understand why I put 30 there? Okay? Over here is 36. Over here is 36. Over here is 33. 33. Over here is 18. There's 18. Now, do you see that 3 sides here match up with 3 sides here? What do we call that? Side, side, side. Does that make sense? Side, side, side. Okay? Now let me ask you a question. Does this angle equal this angle?
Yeah.
Yes. Why? Not only similar, but look, isn't it? All I did was I drew 2 separate triangles. But isn't this the same angle?
Yeah.
It's used twice, right? Once for the smaller triangle, once for the bigger triangle. It's the same angle, right? So not only is this SSS, what else could I call it? I have two sides here and an angle in between.
Side angle side.
I could call it side, angle, side. This could be side, angle, side, or side, side, side. Okay? Does that make sense? KLM, triangle KLM is going to match up with triangle what?
KEF.
KEF. Triangle KEF. Very good. Okay? Everyone good so far? All right. Over here. Now, ladies and gentlemen of the jury, you see these two sides and you see these two sides. What can you tell me about this angle and this angle? Why are they equal? What are they called? Why are they equal? Reflexive is when we use the line, but this is an angle for both.
Is the vertical angle?
Vertical angles. Very good. You remember vertical angles? These are vertical angles, right? Okay. So, why can we say these two triangles are similar? What have we got? We got these two sides and the angle in between the sides. What's that called?
Side angle side.
Side, angle, side. Everybody with me? Okay. So triangle KLM. K is in the center. For the other triangle, what's the center? What's the starting point?
K.
K. Now, K goes straight across to L, all right? So I'm going to go from K straight across to,
T. S.
I'm going to go straight across to S, okay? And then the last one is going to be T. Does that make sense why that works? Okay? Now, it won't always work like that. For example, it could work like this. Once again, I have one angle in each triangle that's congruent. What can you tell me about these two angles here?
They're vertical.
They're vertical angles, meaning they are congruent, right? So why can I say the two triangles are similar? Why can I? No, right? What did I have over here? I have two angles congruent to two angles over here. What was that called?
Angle.
Angle. Over here, I have two angles congruent to two angles. What is that going to be called?
Angle.
Do you understand why it's called angle? Okay, this is angle. Now, here, JKL. Here, I'm starting at J. So for the second triangle, I'm starting at J. But now, in this one, all right, K has two marks on it. What angle has two marks on it in this triangle? Q. Okay? What angle has... What's the last one? P, right? No mark, I was going to say, right? JQP. Okay, does that make sense? Okay? You've been watching the Weiss channel. Da 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 da.